Evening, everybody. Welcome to Innovations Jam's last educational speaking event. We'll be kicking things off shortly, so please mute your mics. Also, as usual with all of our other events, we'll be giving out a really great prize tonight. So make sure that you check the Discord channel Edge-Tech to get the link, and we'll be showing you the password shortly. All right, well, let's get started. The prize password for the day is the word story, all lowercase. So make sure you get your entry in before we choose the winner of the prize. The prize is really awesome. Today's event is Healthcare on the Edge by our sponsor, ACS. We'd like to thank all of our sponsors for all their support that they've given to Innovation Jam, and especially ACS. With that said, I'd like to introduce you to Scot Colmer, the Field CTO of Innovation and Strategy at Pivot Technology Services. Scott has a wide breadth of experience in emerging technologies. Is going to walk you through IoT and edge computing use cases in healthcare, which are sure to play a part in helping older adults age in place. Scott?
Thank you, Michael. Well, thank you, everyone, for taking the time, and good evening. I'll share my screen here real quick. All right. You're able to see the screen okay?
Yep.
Okay. All right. Yeah, as Michael alluded to, I'm gonna touch on a topic around healthcare on the edge, and really this concept of what we're seeing with the evolution of 5G, and I'll get into this a whole lot more, but this concept of multi-edge computing, right? Or multiple edge computing or multi-access computing, and what that looks like from leveraging different connection mediums to deliver applications at the edge in a healthcare setting, and really how that can help change patient-doctor relationships, advanced medicine, help, to Michael's point, help folks in the aging process, leveraging technologies in things like IoT, and really the innovation of around connected devices. So what is MEC, right? So MEC is really a computing and network architecture that brings real-time bandwidth and low latency access to devices at the edge, and really puts the user closer to that application for a better experience, right? So the primary goal of edge is to reduce network congestion, improve the application performance and reliability, and achieve, closer processing, better utilization, better security, and really deliver content to users from an application standpoint, and really change the interaction between, in this case, doctor-patient, but as you could well aware, there's a number of different edge use cases, and we see that, in our daily life. So the graphic on the left here really kind of shows, in traditional enterprise headquarters with some public access networks, and we'll talk about this. This would be your carrier networks, the 3G, 4G, 5G networks, but there's also other connection mediums, be it wireline and Wi-Fi, that we'll talk about. And then as you have these other, campus networks, if you will, how those get connected with MEC devices, and we'll talk about that as it relates to what a MEC device is, how that breakout happens, what those connections look like. So from a high level, that's what MEC is. And really, it's this concept of convergence. When we look at the edge, right, the edge is all about mobility. We look at our devices, our iPads, our mobile phones, our connected watches, all of those IoT devices that are connected through mobility in the core, and from the radio access network, right? As we see more things coming on the network from a 5G standpoint, because there's wider bandwidth, more connectivity, how things at the edge will get leveraged. So it's a convergence of that mobility, the mobile core, which is your carriers, right? The Verizons, the AT&Ts, the T-Mobiles and such. And then the traditional applications, right? So in the healthcare context, that would be, EMR applications. It could be, pharmacy type applications. We'll talk about that. But taking those traditional IT applications, converging them in and leveraging them on the edge, and then leveraging things like wireline, right? So that would be your traditional connections from a wire standpoint. This concept of virtual premise equipment, right? VCPE. And that's how things are run on the edge in a virtual context. And I'll explain that in a bit. And then this whole concept of a broadband network gateway, right? This BNG aspect. And back to that prior graphic, you saw, a gateway. That's really what that BNG is. And then the concept of virtual network functions. So think of that as traditional applications that would run in an enterprise infrastructure on physical hardware. Now they are virtualized, right? So there's virtualization as it relates to those of you that are familiar with VMware and traditional virtualization. But what virtual network functions are really services running on the carrier network, right? So think of virtual services running on a carrier network. And what that really enables is the ability of these devices to, exist on the edge and communicate through the mobility and the core in the radio access network to bring these kind of solutions to bear. So I like to kind of frame the conversations just from a convergence perspective, and that's really what edge is. So if we drill down a little bit on that, so what does deployment look like as it relates to, an edge environment? So I talked about the radio access network. You could have traditional tethered access. So you could have a Mac appliance at the edge that would be tethered from a RJ45 or some other physical connection medium, but there's also Wi-Fi as well. Zigbee protocols as it relates to IoT devices. But essentially what you have is you have the access network, and then you have the underlying compute platform, which in this case is an x86 platform. It can be any white box compute architecture, right? So any of the major OEM manufacturers from an x86 standpoint. And then that combined with, like I said, the virtual network functions, those are the services that would typically run in a traditional architecture, virtualized and running on top of the broader network architecture, right? So things from virtual apps and containers. For those of you that are well aware of what's going on in the space, containerization is really big, and that gives us the ability to break apart traditional monolithic applications and run them in containers that are much more quicker to iterate on. So that is a very good platform to basically run in a Mac environment, because it's much more lightweight. You can secure it better, but then it can be changed much quicker. And that's really what equals that Mac appliance that sits on the edge. So that's really at a high level from a deployment standpoint. I'm going to take it down to a little bit deeper level, just from a conceptual standpoint. So if you look at the orange in the middle here, right? So this is what we call our controller, right? So this is a software hardened platform, a controller that runs applications, right? So this would be those virtual network functions, if you will. And like I had alluded to from a healthcare space perspective, you take electronic health records or electronic medical records, right? That could potentially run at the edge on the edge, from a cloud perspective. We all know like folks like Epic now offer up, a cloud aspect from, EHR and EMR as well. There's this concept of, content caching nodes. So think about something running at the edge in a clinic, in a hospital, let's say radiology, where a radiologist needs to read a radiograph. They don't necessarily have to go all the way back to the traditional data center to read that radiograph. And typically, what you found in those situations is they need very expensive desktops, right, with high-end graphic cards or even GPUs to read those radiographs, from their office or a given location. What the CDN can do is cache a lot of that, right? So in a content delivery network, it's really no different than what Netflix delivers from a streaming perspective, right? They use CDN to cache a lot of that to get the stream better. And in a healthcare environment, you could, on the edge, run these content caching nodes to be able to enable things like, to read radiographs. And then, from a HL7 perspective, this is just a text-based protocol for those of you that are, looking at how to look at possible things to program around the edge. And in this case, it's really the underpinnings or the glue, if you will, between electronic health and medical records around how you engage with your doctor. You go in, you have a visit, they pull up the EHR or EMR, they have all your information in there. You have your visit, they order labs, or they order pharmacy. That basically, gets put through a request via HL7. And if you think of that in a clinic aspect, right? So you go to a remote clinic, you see your doctor, there is a physical piece of hardware that sits out there that interacts with, the EMR system, and then places that order into labs and pharmacies. So what we can do on the edge, if you think about that from, a clinic perspective, we can encapsulate all of those different applications that would be running at the edge into a controller and then be able to run these virtual network functions. On the left-hand side of this is this multi-protocol component of this, right? So whether it's LTE connected devices, and that could be, the phone you see in the screen, an Apple Watch or any other kind of connected device via LTE. And then this concept of small cell that I'll talk about. So if we think of carriers and, Wi-Fi or LTE, right? This ability to not have to talk directly to a tower, let's say AT&T or Verizon, what have you, but this concept of a small cell antenna that sits next to or is part of the MEC appliance that basically allows the communication locally between those devices, allows those virtual network functions to run on the controller inside of the appliance. And then essentially what happens at this bottom layer below is this, the ability of this controller to do edge breakout. So essentially to be able to talk to the mobile network, right? The evolved packet core is what the ECP is. And there's a number of gateways that allow that to happen in the mobile core. But what it is, if you look at 5G, and like I talked about, broader bandwidth, it's not quite there yet, but what we will see in the future is actual private LTE. So they will start to carve up spectrum where organizations and healthcare entities will be able to have their own private spectrum for a 5G standpoint. So you may walk into your provider with your mobile phone, and that phone, rather than it saying AT&T, it may say the name of your healthcare provider. You'd have a secure network, and then there'd be an encrypted channel, into the mobile network operator. But that would be, all via leveraging a small cell antenna with this controller, with these apps running at the edge to be able to do a lot of different things as it relates to healthcare. So hopefully that provides you a good overview from the simple deployment aspect, what that looks like, and then a deeper look into the actual controller. So what are the key points around this? So we touched on this a bit. It's to shift workloads closer to the edge and the user data, right? Doctor-patient relationship, start to ingest a lot more from an IoT standpoint. leverage the aggregation. It's all about low latency see, high bandwidth. And really the 5G being a broader spectrum, more speed, like we all hear about, is going to enable a lot more of this as we go forward. It could be lower cost, increased reliability, in the data transmission. A lot of use cases around artificial intelligence, obviously analytics, autonomous driving at the edge. There's will be things in the future from, an autonomous car perspective where you would be plugging into what's happening on a device, from a health perspective. Maybe it may come through, your vehicle sometime in the future. And this whole concept of, IoT aggregation, which I'll talk about more. The other aspect of it is this platform was built with security first in mind. So identity access and understanding, from, the IoT device to the user, what that looks like from the security profile and how those devices get connected, right? So what are, some of the benefits in healthcare? Some are obvious, obviously, improve patient care, increase patient management. When you look at what's happening, especially, we saw a bit of that, pre-COVID, but post-COVID, I don't know, most of you, I've had, telemedicine, sessions with my doctor and, remote monitoring and things of that nature. When you think of wearables, right, with the help of edge computing, in the reliable, tools for long-term health monitoring and systems, the aging population can leverage these tools to stay healthier and become more proactive, in their own healthcare. And we're seeing a lot of that. And I actually have a use case at the end of that, right? At the end of this year, I talked about increasing that collaboration, smart sensors. It's all a big piece of that. This concept of machine to machine and machine to human interaction. IoT brings, a big component to that, as it relates to how that machine to machine data gets leveraged, for, analytics, and then, taking the, the machine to human interaction. When I talked about the electronic health record system and, Epic, right? Probably one of the, the bigger EHRs out there. And that integration into the HL7 protocol with labs and pharmacy and radiology. So there's a lot of benefits as it relates to being able to leverage IoT, leverage these virtual network functions at the edge that enable a much better, patient doctor, interaction. Example would be, patients undergoing cancer treatment, right, can make use of wearables and the apps to check on the diagnosis and treatment through data collection and, their daily analysis, right? This is also monitor appetite, lifestyle, activity levels, fatigue levels. These are things that the doctor can get more real time on now and really understand where a patient would be, in that treatment process. And, the real time telemedicine is obviously a big piece of that as well. So a lot of healthcare benefits, obviously, from that perspective. So what are some typical use cases? I already talked about a few, obviously, this concept of IoT aggregation, patient management. What we don't see a whole lot of in the healthcare industry, which, this will really be an enablement for, is this mobile payment. So that will become more prevalent, especially now with everything from, a zero contact perspective, machine to machine, machine to human analytics, patient tracking. The other thing about this platform and just Mac in general, as it relates to, the ability to, on the security side, know about the device, but there's a concept called geo-positioning, right? Or positioning over LTE. So back to my earlier scenario where you walk into your care provider, your phone doesn't seamlessly switch, but it would switch from your, let's say, Verizon over to your healthcare. They're now able to track you from a positioning over LTE perspective, and actually, maybe track the patient in addition to movement around. Let's say you were in the hospital, but also with respect to what might be ingested from, an IoT perspective around your, vital signs or things that may be coming off of your wearables. So I touched on a few. Another aspect, with respect to this image here, is the use of edge devices in operating rooms, right? So to be able to do content caching, more real-time analytics, sitting inside of an operating room. One of our customers that we have actually does robotic surgeries remotely, where doctors, it's just a robot, but a doctor remotely is leveraging that. So when you start to look at the analytics that could be pulled inside of from that robot, let's say on an edge device that would feed back to the doctor that is doing that remote surgery, there's a lot of capability there. So kind of broaden this out a little bit. When you look at this from more of a cloud component, if you would, right? So in this case, you have a hospital. This is a radiology, and then you'd have a remote clinic. And this concept of the mobile core, the 5G, the radio access network, the ability of these devices to talk to each other, feed that back into their respective locations. Even from having one of these devices in an ambulance where there is data being taken and analytics, being fed back to the emergency room real time. So I think you can imagine a bunch of different use cases here. But the point is, and I talked about this earlier, it can be done from an LTE perspective. It could be done Wi-Fi in, a given area if there wasn't a small cell. But so multiple connection mediums to be able to merge that IoT in what's called the UE use case, the user equipment use case, if you will. And that user equipment use is, again, it could be a wearable from an individual perspective, or it could be, a monitoring device. It could be that radiograph radiograph machine that you're looking at here, or it could be something that sits inside of, an ambulance, or anything in between. So, we've talked about a lot of these, but I just wanted to throw up something around, some of the remote monitoring aspects of it, wearables, emergency services. I just talked to that. Home care is a big one, right? We're seeing a big increase in home care providers that where, the elderly are leveraging these type of devices. And it can improve their overall health care, and in some cases extend, the quality of life in situations. Again, I refer back to the cancer patient, where you can monitor a lot of, how they're feeling, anxiety levels, fatigue, things of that nature. Another one is, drug system management. This ability to understand disbursement of drugs on the edge, how you track those, and then just point of care systems. We see a lot in the industry around different, point of care systems, whether that's, at a hospital, in a clinic, at a kiosk. There's a lot of point of care systems that are really becoming a lot more viable because of the ability to leverage, compute, IoT, and, the carrier, right, the radio access network from a multi protocol perspective. This is just a little bit deeper on that whole HL7 concept, and really where this is going is this concept of a remote health organization cloud. And I talked about this, going to a clinic where you would have an appointment with your doctor. They bring up your EHR record. They may order pharmacy, or it may be a health kiosk, like I talked about. They may have a radiograph machine at that location, where that gets basically plugged back into that HL7 network. But you can see this whole concept of healthcare clouds, right? And how all of these different devices and connectivity feedback into what that would look like for remote health cloud. And again, it could be insurance companies, pharmacies, it could be kiosks, a bunch of different components that could feed this this aspect of it. The patient aspect, as well, as far as wearables go, this really changes that doctor-patient relationship, and brings a lot more care to the forefront. So the other aspect of this is when you look at deploying these multiple devices, right? Having the ability to administer these, not as islands, but more as from a hub standpoint, and tie these together. So you can see here this ability to do resource management, right? Access control, the onboarding of applications, different health applications. We talked about electronic health records, medical records, the HL7 aspect of that, the ability, from the controller perspective to expose, APIs and, do that breakout, from an edge breakout standpoint. And if you remember back when I showed you the controller aspect of that, the edge breakout on the bottom would be how I would break out network access up to a carrier network from a radio access network perspective to a network that might be sitting on a local segment there via Wi-Fi or even tethered access. This ability to partition that out and do that from a multi-tenant standpoint. And I talked about payment processing. So when you start to think about the concept of mobile access computing, it's not a concept, it's very real. This proliferation, if you will, of devices, how do those get managed across, an organization, right? A healthcare provider in this case. What does that look like? So the ability to do that from, a hub standpoint to push updates, things of that nature, and really automate the consumption of applications. Now, again, whether that's something that may be sitting in, an ambulance, something that, be tied directly to a doctor, on a mobile phone. When you walk into, a clinic, there could be that edge device there. It immediately picks that phone up. You have apps on there from your healthcare provider. How do you manage the ability across multiple edge devices, basically? And that's this hub architecture. So I wanted to kind of wrap up here. I know it's quite a bit. We have some question and answer time coming up, but I wanted to talk about a healthcare IoT aggregation case study we had. So this is one healthcare provider that we work with that, as I had alluded to, through the talk here, where they had, multiple healthcare monitoring devices that they wanted to analyze. They had devices that were sending data at different intervals and timeframes, and they were looking for an architecture and a processing, a controller aspect where they could do this, in multiple locations where they had high volumes, of data, and where latency was an issue. And, they wanted to try and get as close to real time as possible, right? And really to start to understand more of the status of the patient or a device that was changing, if something was en route, challenging. They had a lot of challenges around connecting these systems together securely. And if you think of, obviously healthcare from a HIPAA perspective, really what this looks like, patient records, and then tying all these different components in, from the healthcare professional to the emergency medical services to the scheduling systems, the EMR. So really that was where our platform and solution around IoT aggregation and analytics, right? So I talked about this, the ability to connect with these IoT devices, via either that radio access network or via, Zigbee, other protocols that allow this environment to talk to these devices and really bring in all those different aspects of what was worn from the patient perspective, what was being monitored, what they had inside of the hospital, the clinic, and to be able to really coordinate the appropriate responses if someone was in the hospital, in a clinic, or they were being treated via telemedicine, really what that looked like. And really the benefit to the patient and the care provider is that leveraging the wearables, the Fitbit, the Apple devices, it really enabled the ability to, in this case, something like lower steps, a very high heart rate, a symptom of concern. It would text the person's phone. It would contact their doctor, the healthcare professional. And if the situation persisted, right, it would be, or there was no reply, there could be an immediate dispatch of emergency responders to the patient's house to check on that patient, or a telemedicine instance could be initiated to to reach out to the patient. So there's a lot, as you can imagine, there's a lot of different potential use cases as it relates to aggregating devices and medical records and different sources of data, the x-ray aspect, the content caching, to be able to do that from a very high performance standpoint, at the edge, and bring these multiple data points together to really start to change what that would look like from a doctor patient, and then ultimately the healthcare that is provided, and not just to an elderly patient, but just patients in general. So I'm going to stop here, and I'm going to turn it back over to Michael for the question and answer session.
Thanks, Scott. Showed a lot of great use cases that our participants are going to be able to use in their projects going forward.
I hope so.
So just a reminder, we're going to start the Q&A in a couple seconds here. But if you have any questions, please put the questions in the chat, and we'll try and get to as many of those questions as possible. Just a reminder for those of you who might have missed it, the prize password of the day is story. And so our first question that we'll go with is, what are some of the easiest ways to start using edge technologies at a small scale? You can think that our participants only have 4 weeks to put a project together, and using these technologies, they're going to have limited time and money to spend on their project. So how can they start out small?
Yeah, I think probably one of the easiest ways, and when we think of edge, right, I spent a lot of time on the carrier and the 5G network, but I also alluded to this fact that you could do it with Wi-Fi. So think of taking of something like a NUC, right, an Intel NUC, a small little computing device, a couple $100, and then maybe getting an IoT device where you could work on something by connecting that IoT device via Zigbee. It's a protocol from an IoT standpoint. So you wouldn't necessarily have to go down, a full-blown kind of 5G. You could leverage something small like a NUC, get a Raspberry Pi, right, and leverage that as your IoT device, or find even a camera. We've done this before, where we would have a camera kind of follow motion and things like that. So that's really probably the quickest and easiest way to do that, would be something like a NIC, a Raspberry Pi, leverage something like Zigbee, figure out how you would want to connect to that from an IoT standpoint. And you wouldn't necessarily need to do this with having a full-blown controller like I just showed that hooks into the carrier network. You could run virtual instances on top of that NUC, right? So let's say it's VMware, or if you wanted to go down trying to do virtual network functions on that, which is more more carrier class, but you could do that from running in a virtualized context, right? Whether that's VMware, whether that's KVM, any of that, and then doing it from that standpoint. That would probably be the simplest way.
Okay. And along those same lines, what cloud services would you leverage for a edge or an IoT use case?
Yeah, great question. So if that's from a public cloud perspective, CSP like AWS, Azure, GCP, they all have, we do quite a bit. We integrate with Azure today. So most of the public cloud providers, have their offerings in their clouds respectively. So the ability to take a Mac device and tie into those public cloud providers, from an Azure, AWS, it's not trivial, right? But that framework, from the protocol standpoint, it is pretty much in place because there are standards around this.
Mm-hmm. Okay. One of the participants has a question around securing the entire network on smart edge space, and asked, what are your opinions and techniques for protecting these assets from attackers?
Yeah, so great question. I saw that one up on the screen, and I actually had a backup slide that I left off the presentation that was all around security because it's a key piece, right? And I should have put that in there, but it's a great point, and I touched on that. So when this platform was built, it was built security first in mind. I talked about this concept of identity access or device awareness. So the ability to not only, so the controller that I showed you, first off, is highly locked down as it relates to the Linux operating system that's underneath that. So the attack surface of that is very small. But there's this concept in the industry in security known as zero trust, right? So in other words, if I wanted to go talk with my phone to this environment, there is a one-to-one relationship with my phone and the controller from a zero trust perspective, right? So it knows that my device is what it is, and there is a token, if you will, from a zero trust standpoint. And that's really, when you take any device that would be running on the network, it's really this concept of a zero trust model and a hardened security, profile of the Mac device that's running, and then understanding the positioning over LTE I talked about, knowing what that device is, who that's tied to, and then this whole concept of zero trust.
Great. So we got another question. Do you see edge networks in people's homes playing a part in the health application architectures of the future? Would this allow better monitoring in home AI for preventative health or new applications?
Yeah, so great question. I think that's definitely where it's going, right? So when you talk about edge networks in a home location, right? I talked about that NIC device. That could be something where we see that in the future, where those devices sit, or it could be from your provider today, where those devices sit and function from an edge capacity. We don't see a whole lot of LTE in, there's cards out there that you could do that. You could have an LTE backup to your Wi-Fi provider today to be able to leverage things of that nature. But I definitely see that in the future from, having more turnkey edge deployments in the home to enable the kind of things that we're talking about, from an IoT aggregation standpoint.
Okay. How would you think about an edge solution that's in an internet dark area, low coverage, no high-speed internet, etc.?
Great question. I'd like to be the first one to go do that because I have a wireless connection that's shot to me from 3 miles away, and it costs me $160 a month. So I wouldn't say I'm dark, but it's not cheap. So, again, I think if you think of, I talked a little bit about, the latency aspect of that. So you would really have to understand what the limitations of that, that dark connection, if you would be able to run those kind of things. But if you look at, where, so take, satellite, right? That may not be the best option from the connection media around that, because there's latency, from the up and down streams, right? So I think it's a great question. I think it would really depend on, that network speed, what you were trying to do, what that was being tied into. But I suffer from that a little bit myself.
Okay. Is there any talk in the medtech community around the benefits and drawbacks of brain-computer interfaces, especially as it relates to data collection and aggregation?
Did you say brain collection?
Brain-computer interfaces and data collection.
Yeah, so that's not great questions. Not really an area of expertise that I've been focused on. So I'm assuming that the question is referred to brain waves and taking that data out from a healthcare perspective. Yeah, I'm sure that exists. That's not an area of expertise that I've focused on or we focus on.
Okay.
Yeah.
If anyone else has any questions, just a reminder, go ahead and put them in the chat.
I agree, Lucy. That would be pretty cool from a brain collection perspective. But
so another question would be, all of our participants have to do presentations to pitch their ideas. So what are some points or insight that you can give to how you go about presenting to executives some of these technologies? And they can be difficult for some people who don't have a background in tech specifically.
Yeah, I mean, that's a great question, Michael. And when we go into customers, it's really about understanding that need, right? As you can see, we only had an hour here, and stayed fairly broad on the topic, and there's a lot of potential options. And if you look at just the expected kind of explosion of IoT devices through the next 10, 15 years, right, is astronomical. So when we go in and have a conversation with our customer, we need to get very specific around what use case that they are trying to solve. And then, understand, in the case of the healthcare that I was talking about, it was really all about trying to get multiple sources and aggregate those in from an analytics perspective. So I would think really flushing out, what the use case, what the need is, and then aligning that right piece of technology around it. Because like I talked about, it may not be, in initial aspect of that, it may not be, LTE, leaning, right? It could be something that would be simply Wi-Fi based, or again, from an IoT standpoint, more of a Zigbee protocol. But if it was something where you're looking at a device that's LTE connected, so I think you really need to flush out what that use case is, what the underlying pieces of technology is, and then kind of work back from there around what pieces of technology fit that. And there's a lot of technologies on the market as it relates to edge compute devices, right, that have the ability, they're x86, like I talked about, but have small cell antennas built into them, right? Mm-hmm. That we leverage to where you're not having to go, buy another small cell antenna, hook that up to the platform, and then start to leverage that. So it's really about, I think, targeting that use case and then working backwards from the technologies.
Okay.
Asking the right questions, basically, around, what the ask and need is from the customer and client.
Okay, great. So we got another question in. Will healthcare regulations and standards be able to keep up with the coming surge in IoT and potential medtech applications?
Yeah, great question. I think obviously there's nothing more rigorous than, HIPAA and, PHI, right?
Mhm.
So again, I think that's all about that security construct and how a new device from, a med tech or application comes into the mix, right? I think I alluded to the containerization aspect of it, right? And the smaller attack footprint and things of that nature as it relates to the applications. I think it's all on how, if you start to look at things like even serverless, right? Applications, things that aren't tied to hardware, that wouldn't necessarily, be a container. I think the ability to secure the applications easier is going to make that, transition from, leveraging an IoT device, much more, the potential much higher.
Okay. You went through the use case that your company did with the healthcare provider. What did you see as the acceptance of the actual patients themselves? Technology tends to be the easy part, and the key thing is trying to get adoption of whatever that technology is by the actual users. Did you have a good acceptance rate? Were there challenges?
Yeah, I think from the patient perspective, they were a little bit removed for this. This was working with our client around like the monitoring devices that they would be wearing if they were in facility, right?
Mhm.
So it was a bit more on that aspect of it. It ultimately translated to, better insight and better, care and interaction with the patient, but we didn't actually poll the patient on that aspect of it. So it was more of a byproduct of us fleshing out the technology and the use case with the client. Does that make sense?
Yep. All right. Any additional questions?
These have been great questions.
What med tech would most help prevent the future pandemics?
Um, well, obviously, all the zero touch stuff that we're seeing today, right? Heat sensors, when you walk in, facial recognition. We actually do some things with, um, uh, some customers around, facial recognition when you walk in, see if, you're flushed, if you're sweating, right? The ability to take a temperature on somebody without actually having to, put a gun up to them. So
Mhm.
we're working with solutions around that. So I think anything where it's zero touch, I think would be, really beneficial to, preventing future pandemics.
Okay, great. All right. Well, we're gonna continue on here. All right. So just a quick reminder. Um, any participant who submits a project by the deadline will be entered in the drawing for the grand door prize, which is a Microsoft Surface laptop. So make sure that you get your submissions in on time. Today, we've got an awesome door prize. Microsoft has donated a Microsoft Surface Go, and we're going to give that out right now. So, Scott, can you tell us who's taking home the Microsoft Surface Go tablet?
I can. I think. Let me get here. Yep. So congratulations. The prize winner is. I think I'm gonna botch this, but Anjali Suridan.
All right, that's awesome. Congratulations.
He's happy about
It's a
that.
great tablet, and we'll get with you tomorrow on getting that sent out to you. So thank you so much, Scott, for coming out and presenting to all our participants. You gave us a lot of great insight into IoT and computing on the edge. And as I mentioned, I'm hoping that this helps all the participants in building out really awesome projects. And just want to thank you again, and we appreciate everyone coming out to the event tonight. And be sure to get your time with your mentors scheduled for next Monday and Tuesday if you have not already done so. We look forward to talking to you then. Thank you, everyone. Have a great evening.
Thank you, Michael. Thanks, everyone.
Thank you.
Thanks.